Okay, so this is about pool retirement and protocol simplification. And I'll get to what pool retirement means if you don't know. This talk is about something kind of messy, but I think necessary to discuss. So it's less sexy than a lot of the other talks that are introducing exciting new developments. And it's pretty ironic because I think when most people hear pool retirement, they might think of something like this. But this is not nearly as pleasant. Okay, so I want to kind of start from first principles and give a background about like what this is and why we might want to do it. So generally, we want Zec to have long-term sustainability and socially, economically, and technically. So the technology needs to evolve over the long term. And any technology, as it's evolving, naturally grows more complex. And so technologies that survive over long time periods also need a way to reduce complexity as they evolve. So there's a motivation to do that with the Zcash protocol, but there are some sticky parts to the Zcash consensus protocol when it comes to simplification. So some examples are the storage of funds, which this talk is mostly about. Another example might be addresses, because people share and use those sort of outside of the protocol itself. So that's just another example. And why do we want a simpler protocol? There's a bunch of reasons. If the protocol is simpler, generally it's easier to explain to people. And the easier it is for people to understand like what Zcash is, the better they can make an informed choice if they want to use it. It's also easier for products and services to integrate a simpler protocol versus a more complex protocol. So that could be good for adoption and sort of expansion of the ecosystem. It's also good for the core protocol maintenance and development itself. If you have simpler code and code bases, it's easier to add new features or fix bugs or sort of understand the system and how it works. And then there are multiple security reasons simplicity is better. So you want people analyzing security to have less stuff to track in their heads so that it's easier to reason about if something is safe or not. And anywhere there's complexity, there could be bugs lurking that we haven't found yet. So the more complex something is, the worse that is. And then finally, over time, there can be security breakthroughs in cryptography or other kinds of code that might emerge long after a certain technology has been deployed. So it's good to be able to retire older technology over time generally for that reason too. So there's some easy stuff. I put easy in quotes because it's still hard and a lot of work, but there are things that are much easier to simplify out of the protocol over time. So for example, we can create new node implementations and retire old code while maintaining the same consensus rules. So a great example of that is Zebra, a new node implementation that's coming online. Network protocols, rather than the consensus protocol, are more nimble. So that's how do the nodes talk to each other, how do wallets talk to the network. Those only operate while the nodes are in that interaction. And so it's easy to create new network protocols over time and retire the old ones without disrupting user experience or consensus. And then there's a lot of non-consensus stuff that's easy, like what format does your node or wallet store data on disk? You can change stuff like that. So that stuff is much easier. Consensus rules are harder, but we've already shown in Zcash we can upgrade the consensus rules. you just have to be judicious about it. So what are the hard things in protocol simplification? Anything affecting user behavior or user expectations can be hard. And users can learn and change. So it's sort of a gray area that requires good judgment to know when and how user expectations should be changed and how to go through that change. But some expectations might be really fundamental to like the whole reason they want to use this thing. As I mentioned before, addresses and any other way users communicate or share information about the protocol that's sort of outside the protocol itself can be harder to migrate, because if we change the protocol, people still want to use that information, like addresses that aren't stored anywhere in the protocol. And so finally, I put here any consensus rule changes which disrupt fundamental user expectations. So maybe you have a user expectation about how much fees should be, and then maybe one day fees change for whatever reason, like we change the consensus rules or the blockchain gets full and fees raise or something like that. Well, I would guess most users can understand and adapt to that. So I don't consider those fundamental. But I assume users have some fundamental expectations or beliefs. And so I have a bet that many users have expectations around the supply cap and the issuance schedule, because that was something about Bitcoin that was like novel and unique, and Bitcoin was the first, and people sort of wrapped their heads around it as they learned about cryptocurrency. And so for a lot of people, that piece is like an important part of what they think of Bitcoin, and I assume Zcash. So there's probably others, like I just mentioned the supply cap and the issuance rate. So the thing about user expectations, though, is that they're tricky. It's hard to know. It's hard to know even who the users are, first of all. And then beyond that, it's hard to know what they expect or want. And sometimes I think maybe even they expect or want things that they are not aware of. So it's a very tricky business. And I also point out here that there are many Zcash users who may not even speak English, many who aren't like directly involved in like this community or on the forums. So it's a very challenging problem. So sort of the punchline here of this talk is that the only way to retire old funds is by the protocol moving or destroying them without the user taking any action, which is just a sad truth. So I have a sad cat face. So if we were going to choose to do anything like that, we should definitely be very careful and not do it rashly. And I think this is a fundamental trade-off where if we want to retire if we want to be able to retire any part of the consensus rules, that will include users' funds stored in older transaction formats or older transaction protocols. And it's a fundamental trade-off. So we either have to decide that we're going to be able to retire old tech generally, including some of the old transaction technologies, or we have to decide we're going to preserve funds indefinitely. So it's a trade-off, and I think that you know, each side is like self-consistent, and so yeah, that's the tricky thing about trade-offs. So I have this table here where I pointed out that like there's a principle behind why you would want to do either. So either choice can be principled. So maintaining funds indefinitely is sort of fulfilling this principle that we always preserve users' money, and that's just like an imperative. Preserve their money and their control of their money. The other side, the principle is we need to reduce protocol complexity to protect all of the users, because one of the motivations is to improve security and resilience and adaptability of the protocol. And if we don't do that, we're sort of doing a disservice to all of the users. And we're putting them at risk for maybe bugs or security issues in older code. The next row is sort of about a social contract. So if we as a community kind of all agree and consent on this principle of always preserving users' money, then users are sort of relying on that norm or convention or standard to also last indefinitely. So there's obviously like maybe some edge cases. What if in 20 years there's just like a different crowd and they just decide a different thing? I mean, that kind of issue is present with a lot of our norms and social agreements. Like it's also true of the issuance schedule and supply cap. Like that could be changed one day by a different group of developers down the road. We don't know. So it's just important, I think, to focus on the fact that that is sort of a social norm or contract that people would rely on. On the other hand, if we generally have this notion that we retire old tech, and sometimes that means removing user funds, then what users are sort of relying on is that that process is clear and they understand it and it gets carried out successfully. But it seems, for any given instance of the process, a little more temporal. So what I mean by that is the Zcash protocol might go through that process for some time and then later not go through that process. But since it completed that process in that instance, the users who are depending on that process, their expectations have been satisfied despite what happens in the future. If we go with maintaining funds indefinitely, then new protocol changes are always going to increase complexity of the protocol. And if we go with retiring old funds, we can retire old complexity to simplify. So that's sort of how those stack up in my mind. So what is pool retirement? The reason we're talking about user funds as connected to retiring old technology is that there are different transaction rules in Zcash that have been evolving over time. So there are transparent transaction rules that come from Bitcoin. There was the first shielded technology we launched with called Sprout. There's the newer one that has been much more used because it's much more efficient. It's an example of why we need to evolve the protocol, called Sapling. And now we've deployed this newest protocol called Orchard, which has other improvements such as removing sort of the trusted setup problem and a source of systemic risk. So funds use those different technologies and they can interact within a transaction, and users can transfer funds around, and each of these technologies is associated with an address type. And when funds get sent to an address of that type, they're relying on that kind of technology to store them and to enable them to be spent later. So we refer to all of the funds stored by each kind of technology as a pool. So we say the sapling pool or the orchard pool. And in terms of reducing protocol complexity, what matters is the pool itself, because that's the unit of technology that we're talking about potentially retiring. Okay, so if we're going to, so we need to retire pools if we're going to remove the technology. And so we might think about, if we want to do that, we could have some process that sort of applies to a pool itself. Or we might have a process that generally applies to all funds, and then just as a side effect, sooner or later, a given pool can become empty and then be removed. I haven't thought too much about that latter case of like just having a general process and rule, but it's kind of appealing to me because it would be very consistent for users to understand. So I'd like to explore that one more. Okay, so here's a user persona and a user story for the hard thing. So we have Jolly MP3s, who's a pirate, and they took a seed phrase from Zcash long ago and took it to a remote island and buried it. And maybe one day one of their successors will dig it up, but we don't know how long that will be or if it will ever even happen. So that's like, you know, it's humorous, but it's representing a really real issue. There are people who do have seed phrases who have intended to store them for a long time. Okay, often when we've been talking about these kinds of topics, like at arborist calls or around the community, people love brainstorming different potential solutions, and I think it's natural for people to kind of want the best of both worlds. So maybe the trade-off that I was describing earlier isn't fully clear to them, or they don't believe that it's actually a trade-off and there's some way to get both. So I wanted to explore just a few example ideas I've heard, and I think they show that they never get around the trade-off, but they can shift things around in potentially valuable ways. So we should keep thinking about them, but I don't think they ever get around the fundamental trade-off. So like one example is, what if we have sort of a second tier or an offline batch validation process for old funds. So let's imagine we do an upgrade to Zcash in U6, and now normal full nodes no longer need to validate anything about Sprout. So all the Sprout code can be deleted from them. And maybe we can remove the Sprout fields from transactions, so those get simpler. So this makes things simpler for wallets to integrate and for those nodes. So that seems appealing. And then we have some other way for users who, like Jolly MP3s, buried their Sprout funds, can show up to this other second tier or offline service and like generate a zero knowledge proof to prove that they do have these Sprout funds. And then that service can validate those proofs and sort of bundle those together, and then somehow, this is the trick, they get those funds back onto the main chain. So there's different ways to do that, and one might be like when we release upgrades, we validate all of those old Sprout proofs, or like an aggregate proof of all of them, sort of off-chain, and have multiple people review it as part of the upgrade. And then if it passes muster, it gets sort of included as a snapshot in the upgrade with those funds now in newer pools. So this is showing how we can sort of shift around some of the responsibilities and trade-offs. So this does have some potential advantages because like new wallets, for example, don't need the Sprout code. But ultimately, there still is some need to validate the Sprout proofs in this system. So that complexity is still there. We've just sort of like pulled it off chain and added this new process into upgrades. So I think overall, the system is still complex. We've sort of shifted the complexity around, which may still be valuable. But I think for the fundamental trade-off, we haven't simplified the whole complexity of the system. And this kind of approach has some other things that worry me. So one is it might be pretty rare for Jolly MP3's descendant to show up with Sprout. So maybe that happens rarely. So it's just a few users per year or something. And so they're going to need to use like a Sprout prover or something, and then the second tier or batch validator needs to use the Sprout validator. And the question is, how often do they use that, and how do they know it works? Can they download it? Is it bit rotted? I'm always sort of leery of tools that aren't used frequently, because I think it's very natural for things to bit rot or be poorly supported. And then there's this other issue. In this approach I described, there's like this separate batch processing system whose output goes into like an upgrade candidate for everyone to review. But who's running that system, that may be introducing concerns like around transaction censorship. What if that's a small group of people and they just don't like Jolly MP3s? Okay, so another exploration is what I'm calling the Uber circuit. And so the idea here is instead of using the currently existing Sprout prover and Sprout verifier, we encode all of the same logic necessary for the Sprout funds into a modern circuit, and we just have this one circuit for the modern protocol, and it just knows how to validate all of the old transaction types. And so like the naive approach is just one monolithic circuit, but you can be more sophisticated and have like nested circuits that specialize in the different subcases, and maybe you can improve performance and stuff. That's not my my lane, so I'm sure there could be a lot done there. And this does show that we are shifting around complexity, because now instead of multiple proving and validation systems, we've removed all of those and we're using just a single proving and validation system. So in terms of analyzing, is the protocol secure, and also in terms of which code we need for proving and validation, that has become simpler. And if we can like do security analysis of just that proving system and we have high confidence in it, that's good. And it's perhaps less work than knowing about all of the other proving and validation protocols. So that is pretty interesting. There's another fun, just little tidbit here, like what if we made that circuit so that it could validate all T-adders also? So just one day they instantly turned into shielded. But so those are some potential benefits. But now costs, the validation rules are still just as complex for all of the old, it still includes all of the old transaction types. So we've sort of moved some of the complexity from older circuits all into this one big circuit. So now it's going to be bigger and more complex. The naive monolithic thing is probably not very performant. So one reason we want to have separate specialized circuits for new transaction types is so that we can optimize them for performance. And now there's a similar issue. Let's say we do find performance improvements and we have a more sophisticated circuit structure, but we still have the sort of issue of, well, how often do the older circuit logics get exercised? and do the provers work for that sub circuit, and do the, like, are there wallets that can do those proofs? All of that, all of those issues around rarely used features also show up here. So a third brainstorm, what if we just have two different blockchains now, and there's like the newer, prettier blockchain. This story is very appealing to me, by the way. There's like a new pretty blockchain that's simple. It has like new consensus rules. It's much more efficient and fast and scalable. Totally awesome. And its transactions are a lot simpler, so it's easier to deploy wallets for and so forth. And now we keep the old chain with all of the old stuff, and we have some sort of cross-protocol bridge, which might be a hard sell since we've seen so many bridge hacks, but I think we could probably make a safer one. And so this is also an example of just like shifting around the complexity. So it does seem kind of appealing, like if you have a wallet that only supports the new chain, that's good. But now, what if you need to interact with users who are using the old chain? Are you going to need a different wallet? If you have a wallet that can talk to both chains, that wallet's going to be really complicated. So we're sort of just, again, pushing the complexity around. And it still has the infrequent use issue. Like, if few people use the old chain, how well will it work? Will it be really buggy and bit routed? And yeah, one last piece here is, even though the two chains may have their consensus fairly decoupled, it's still the case that, like, if there's a counterfeit failure on either side, that harms all Zec users across both chains. So there is some compartmentalization, but we haven't escaped the interactions completely. Okay, so those are just some brainstorms. I'm sure there's a lot more, and I do think it's worth exploring how we can move those pieces around a lot more. But I wanted to do that tour to sort of reinforce that I think the fundamental trade-off is still there between always supporting user funds or retiring old tech, which requires removing user funds. Okay, so since there is a trade-off, I'm a big fan of being very consistent about making trade-offs and being clear about that. So whenever there's a trade-off, one option is go all the way one way, one option is go all the way the other way, one option is sort of like try to find a balance. But I think the most crucial thing in any of those three options is to be very clear that the trade-off exists, and to define which of those three positions we're taking and make that really clear to users and future developers. And the two extremes here, again, are support all old funds forever and therefore accrue complexity forever, or reduce complexity, which will require retiring old funds in some way. Okay, and then there's a second order problem. Let's say we choose any of those three options for the trade-offs, but then again, future Zcash community or developers might switch to other trade-off, like another trade-off choice in the future. And so we should just be really cognizant of that and try to notice if proposals are doing that, highlight the fact like, oh, well, there's this trade-off. Historically, we've done this, or we even had a discussion and agreed to do this, and this changes that. So let's talk about if we want to change that, or if that wasn't apparent when this proposal was created. Okay, so how do we retire old funds? Okay, so the obvious, easy, the nice and easy thing that just will never happen is if all the users on their own consensually just decide to migrate their old funds away from the old tech. That would be awesome. And we can never achieve that fully, I believe, but we can still, there's still a lot of room for improvement by just educating users that it needs to happen, or working, for example, with wallet developers to help users know that it should happen and streamline that process and make it super easy for them. So we should keep paying attention to that. But ultimately, we can't guarantee every user will do that. We don't even know if we can get messages across to users outside of the direct user experience they're dealing with, just because of language barriers and the fact that we don't know who all the users are. And finally, people lose seed phrases and secret keys, which is terrible, and we should fix that problem itself. But for now, that's certainly the case. So what this means is from outside, looking at the chain, thinking about the protocol, we can't ever tell if there are funds sitting there, if that's because a user wants them to be there or somebody lost their keys. So the nuclear option would be like one day we want to turn off Sprout and we just delete all those funds. That's terrible. Nobody wants that. I just bring it up because I like to sort of delineate the entire space of possibilities, even the really terrible ones. So what does that leave? To me, it seems like the only other thing I can think of, I could be missing other options, but is to have some kind of fee that gets imposed on those funds. So also, I think these fees should be focused on the storage of the funds, because what we want these fees to do is incentivize users to migrate their funds away. So if these are fees sort of on that are assessed based on the transaction cost or something like that, that might have the wrong incentive. Like they might want to not move their funds so that they don't have to pay that fee. So it seems like we need some sort of fees on old funds that are sitting around if we want to be able to retire old pools. Okay, so here is like a mechanics discussion we had at ECC on the engineering team about, okay, well, technically, what are different things we can do with old pools to sort of figure out what the different possibilities are and what that might look like for pool retirement. And so we came up with these ideas that we knew were feasible to implement. And we came up with this concept of a pool state, like a life cycle state, and gave those names, and then sort of defined at a very high level what the functionality of that state would be, and what the requirements would be to implement or deploy that kind of state change. And then what functionality there is. Can you transfer funds into that pool? Can you transfer funds around within that pool? Can you transfer them out? And also how that interacts with the turnstile. So in Zcash, we have this concept of a turnstile between all of the pools. So you can sort of think of like there's an exit turnstile and an entrance turnstile for any pool. And a property of the turnstile is when funds come out of an exit turnstile, the value is public. And the rationale for that is to have like an accounting for how many funds are in any given pool. Even though within the pool the funds are shielded, we have this public tally of the total amount in the pool. And there's a few reasons for that. One would be we can add those totals together to know what is the total supply. But another important one is if there were a counterfeiting compromise or vulnerability in one pool, the turnstile would prevent more funds from leaving that pool than should exist in that pool by this external accounting. So it's sort of like a belt and suspenders kind of protection against counterfeiting. The very first line of defense is we want to make sure the proving system is secure. But if that fails, there's a second line of defense. These turnstiles give us this lever if we're going to do pool retirement. And we've actually already used this once for the Sprout pool. So what we can do is just disable the like the ingress turnstile, which is what we have done for Sprout. So it is not possible to send funds from outside of the Sprout pool into the Sprout pool currently in Zcash. So again, this is sort of a brainstorm of what's possible. I don't suggest we use all of this, and I'll give a more specific proposal of, like a straw man proposal of what pool retirement could look like later. Here we go. Yeah, so all of this talk about this hard trade-off is right here in this transition between the upper part of the table and the outer part of the table. So out means, can funds go out of that pool? If they can, the users own and control those funds. They may not be able to transfer within the pool. They may not be able to transfer new funds into that pool, but they can transfer them out, so they still own and control them. But once we get to the X's on the out column, they can no longer transfer out of that pool. They can no longer transfer those funds to the rest of the Zcash network. So in order for that X, like in order for us to go to either of those bottom rows, this is effectively disabling those funds. And the distinction between the two bottom rows is whether or not that is temporary, because we realize if we want to have these sort of levers on the turnstiles for different pools, it may be the case someday that there's an emergency, which we believe we could fix over some time, but in the interim, it's best to sort of like freeze a pool until some sort of bug could be deployed. So that's a little bit different than a little bit of a tangent from the main thrust of this talk. But we found, as we were exploring this, oh yeah, that's something we should be thinking about while we're examining all these levers here. And then the bottom row is like, okay, if you can't send funds into the pool, you can't transfer them within the pool, and you can't transfer them out from the pool, and that's a permanent change, then that pool no longer exists. It's removed, and that means we can delete the code and update the spec and all that good stuff to actually simplify the protocol. So that bottom row achieves the goal of simplifying the protocol. There's this legend with these different symbols, and you see like the nuclear alert symbol on the bottom row there, and that means user funds are permanently destroyed. So here's this idea of how we could do that in a less drastic way than one day just blowing shit up. So the idea is there's some sort of fees, and those fees would have to eventually cover all of the, eat away all of the funds in a pool, because we want to require that the balance of the pool is 0 before we delete it. So this, going down this exploration, we could have something, I was just thinking of it as a legacy hosting fee. So the way to describe it to users is, your funds have been in this old account, and maintaining that account is a cost to all the other users because of the potential risks or bugs in this older technology, and it's a cost to all of the infrastructure because they have to continue to validate and process these kinds of transactions, and it's a cost to the developers because they have to keep maintaining that software and so forth. So we're going to impose a fee on that. And so hopefully that would stimulate users to transfer those funds to a new destination that doesn't have those fees. And now, how can we get the pool balance to be 0? Well, that means the fees have to grow until they've finally reduced all of the remaining funds. So hopefully that should only happen to lost keys, but it might happen to users who just aren't paying attention. So we probably want this process to be slow over a long time period so that like they'll hear from their Zcash friends like, oh man, I had that fee, I had to do the thing. And they'll be like, what are you talking about, right? So hopefully we can get, with a long enough time scale, we can minimize the harm that happens to users. So this is just a specific proposal that sort of ties these ideas together. And the idea is, hey, if we're going to create a new pool in the future, let's have a non-discretionary schedule, which I'll talk about non-discretionary later. And so it just sort of has this clock. As soon as it gets deployed, it's on this clock. And it automatically transitions through these pool life cycle states based on that clock. Of course, if there were like an emergency, we might somehow interfere with this process. But generally, we want this process to just carry out as is, and everyone sort of knows what the schedule is up front. So the pool begins, and these times I just made up. I just picked them. So we should think about those more. But so I had these timelines for these phases that I just made up. So when a new pool is deployed, it's active for 24 months. So you can send, receive, store, and so forth. And then after 24 months, it enters the closing state, which is a name we made up in that table. But that the Sprout pool is currently in the closing state, even though we didn't have that terminology when we disabled the incoming turnstile on Sprout. And so what that means is there's no fees. Users aren't losing money. It's just that you can no longer send funds from outside that pool to inside that pool. That goes on for 6 months, and then it enters a penalized state, which is the same as closing, but now there's this fee. And a simple way to do this fee that works well with shielded technology is that that has some warts, is that when funds exit the pool, the value is public. So at that time, the fee is assessed on that amount of value. So this has some implications, like if users are transferring funds around within that pool, that fee would not apply to them, which might have some weird implications. But it's easy to implement and understand. And over 24 months, that fee just ramps up from 0 to 100%. I don't know if 24 months is long enough or the right thing, but that's the idea. There's just this slow ramp. So at the end, when the fee is 100%, any funds that remain are all consumed by the fee mechanism, because if anyone tried to go out of the turnstile, 100% of that amount would be a fee. And so there's no need to wait for that. There's no difference between waiting for that and just considering all of the remaining funds as being collected as this fee. And so at that point, those funds can be moved by whatever fee, however the fee mechanism, whatever the destination is, those funds can go to that destination, and then the balance is 0, and that pool can be deleted. The state required for tracking that pool by consensus nodes can be forgotten, or it could be pruned for future nodes. Nodes that might want to do historical validation will still need to track that state, but once they get to this height in the blockchain, they can sort of drop that state from memory and continue their historical validation. So here's this thing I also suggest that's sort of on top of that, but they are separate. We could do them separately. And this one is contentious. Like we've had discussions in Arborist calls or elsewhere. And again, there's some trade-offs and different opinions. But I'm just going to bring it up here. So the idea is not only do we have that sort of non-discretionary life cycle for any new pools, but we also just have a regular clock that just starts a new pool every 12 months. And I'm glossing, yeah, there are many challenges with this. Oh yeah, one other thing is usually, so far historically, we've only created a new pool when we have upgrades to the circuit functionality, such as new proving systems or things like that. But in this case, we just have these timed events where new pools are created, and so those will just use whatever the latest technology is ready at that time. And if there are no new changes, then that new pool would just reuse the same technology as the previous pool. So why? Why do this? One reason, I think, is that if this cadence is very regular and the pool lifecycle timeline is non-discretionary and fixed, then everyone sort of learns what it is. It's sort of this rhythm. Everyone can adapt to it. So users sort of know what to expect. Vendors, ecosystem, infrastructure, people all know that it happens regularly. There's another motivation I have, which is that if we're doing this, then when we want to upgrade transaction technology, we can sort of slot it in to this process instead of having a sort of separate process that that is sort of more bespoke to that particular upgrade. And UX of different products and services can reinforce this. So like if there's this regular timeline, for example, wallets can help users know that this is coming up and help them manage their funds. But again, that's on top of the previous one. So the previous one was called Pool Lifecycle, which was just about a single pool going through this process. This thing, rolling pool lifecycles, could be built on top of that, but they are separate. And I think some people might support the former, but not the latter. I guess I should mention some downsides of this. So one is right now it's a pain to have a new pool because it requires a new address, and then users, it's really disruptive to like rotate addresses because maybe a user gave out an address to a friend, or maybe it's saved in their transaction history and they're just going to reuse an old address. I do this. I go through my transaction history. I know I sent someone a payment and I want to resend them a new payment. I just recognize their address by like visually, so I'm like, okay, I'm going to just resend there. And I usually don't ask them, hey, do you have a new address? And that's dangerous, especially in this kind of world. So there are definitely challenges around usability especially. But I'm kind of an optimist, and I think we could design really good UX that can protect users and overcome that. Okay, so yeah, actually, okay, let's think a little bit about UX. What does this pool lifecycle proposal mean for UX? So I'm not a UX expert, but I just brainstorm. We definitely probably want these two pieces. So we don't want users to know what a pool lifecycle is. Like they shouldn't have to even hear that phrase. And they definitely shouldn't have to know like dates or anything. So their wallet they should open it one day, just like when you open, I don't know, say Chrome browser or your operating system, it says, hey, there's an update. If you want to apply it, click here. I think we should probably have something similar, like, hey, you need to upgrade. You really oughta before this date. And to do that, all you got to do is click this button. And we should really make it as easy as just click the button. But now the challenging thing is the Jolly MP3's use case. So Jolly MP3 used some tool to print a paper wallet or a metal wallet or something to bury. Wallets in that printout that has a seed phrase should also say very clearly, hey, funds transferred to addresses derived by this seed phrase will begin to expire sometime after this date. So you must like restore before this date. That's not the best story for the Jolly MP3's use case. And maybe there's something better in terms of UX, but I think at a minimum, we should require wallets to do that. Okay, so this is, I shared that proposal. It's making that trade-off a certain way, because I tend to lean that way. I think we should try to simplify the protocol over time. But I'm biased because I work with a team that has to maintain a bunch of stuff all the time, and it's a lot of work. But I wanted to talk a little bit about principles and social contract and consent. So the biggest problem with this proposal, in my opinion, is user expectations and thus consent. So remember in the proposal I said if we have a new pool, we can do this. But that won't, unless we retroactively apply this to existing pools, it won't ever help with those older pools and removing those from the protocol. So my big concern is that users of Zcash started with a bunch of assumptions and based their behavior on that and made their plans and commitments based on that. And it's very likely that one of the assumptions was if you have a seed, the funds there last indefinitely and you can use it forevermore, which I think we've inherited from Bitcoin and is very common across the cryptocurrency industry. So I think it's very likely most people have that expectation. So there's no way to apply pool life cycles or the legacy hosting fees to those old pools without upsetting that expectation. So that's just sad news, basically. We got to choose one or the other. But I do think it's better for users of new pools because as long as we have really good UX and there's also this user education component, the ideal is people who choose to use Zcash are doing so consensually, which requires them to be well informed and understand what's happening. That's the ideal. I think in practice, it's always hard to ever achieve that ideal because many people have different beliefs. People might not even realize what their beliefs or assumptions are. They might have false beliefs or assumptions, but since the technology never challenges those false beliefs or assumptions, they persist. And there's another challenge aside from just this consent issue, which is just, will this harm adoption? If you're thinking, hey, I'm interested in this Zcash stuff, how do I get started? And the wallet pops open, and it's by the way, you have to, in 1 year, you have to push this button or else your funds, or else there's this fine. Users might be like, well, why am I going to use this versus something else that doesn't have that problem? Okay, so I wanted to say the proposal I had was just one sort of package of some ideas. There might be other things that we could do or decide to do, but I do think we should maintain some principles. If we're going to go the route of retiring old fees to reduce complexity, I think we should have a few principles that I advocate for. So one is to minimize discretion. So that's why in my proposal for pool life cycles, there's just a fixed clock that the pool goes through. An alternative would be we have these life cycle stages for the pools, and then each time we're doing an upgrade, we decide for that upgrade, should we advance this to the next life cycle based on whatever considerations we have, maybe market considerations or whatever. I lean fairly heavily against that if we can avoid it, because then this means every upgrade, the development community would have this sort of discretionary power that whichever decision we make one way or another, we're going to be upsetting some portion of users' expectations. And I just don't want to be in that position. and I don't think we need that sort of discretion for this kind of proposal to be successful. The next one is just a clearer process. So like, what are the rules for the different stages in the life cycle, and when do the transitions occur, and how much are the fees? All of that needs to be crystal clear for all users and wallet developers and so on. And then again, I've talked a lot about UX, but I feel like a lot of the lift here would be ensuring that wallets are consistent across the board in explaining to users and helping users navigate this. Actually, not explaining to users. Explain to users as little as possible and help them do what they need to do safely. And give them a link if they want to learn in depth. So this is just parting tangents. So if we were going to adopt some sort of pool retirement process retroactively for existing pools, one option is we could use that process on transparent addresses. And this is a thing in the community where different people advocate for different things, but some people in the community want to retire transparent addresses. So if we already had this framework, it just makes sense to me that we could use it, and so the process of doing that would be sort of consistent with everything else. The other one is a tangent. Where should the fees go? Like a very basic, simple proposal is they would just go to the miner or something. I just published a blog post last week with this proposal for something called the Zcash Posterity Fund. And so this is totally separate from pool retirement, but if we had both, fees could go into this Posterity Fund. And so a quick summary of what is the Posterity Fund is just basically a way for fees to pay out to future block rewards. And that's basically it. So like, instead of paying fees directly to miners, you save them in an account and slowly dribble them out to future block producers. That's the basic idea, but there's a blog post if you're interested in that. All right, so questions?
So you had quite a few questions, but you're extremely adept at answering them through your talk. I think one that you didn't answer is, could we have a long Zec type of pool that maybe is never retired and has a slower pace?
Yeah, we could. I feel like that fits into that sort of middle section, whereas brainstorming how we can move around different trade-offs. So yeah, we could have like a long-term pool or something like that. And I would say if we do build something like that, maybe we could tailor it specifically for the use case of long-term storage. So for example, maybe you can't even do transfers in it. All you can do is like put funds there and later withdraw them. Maybe making simplifications like that could help that sort of simplify the cryptography or technology we need to do that, because if we're going to have that, we definitely want it to be as simple as possible to remain secure for a very long time, like indefinitely, which is a big challenge.
Maybe time for one more question. Can transparent addresses still be used for long-term storage?
Well, yeah, so this is touching on a really interesting thing. So if we apply pool retirement inconsistently, so we've kind of started doing that without as much reasoning or understanding of this issue with Sprout. We just turned off the turnstile. This is before we had this like notion of pool retirement altogether. If it's not clear which pools we're going to do that with or not, then if people assume we're not going to do it with some pools, they might use those pools as long-term storage. In my opinion, if we're going to do it, I feel like we should do it very consistently. Because I feel like that would be an example of people building an expectation and relying on it, even though the protocol developers aren't explicitly aiming to support that. And that's where you get into trouble, because later the expectations may be upset.
Awesome. Well, thank you very much.
Yeah.
That was great.